All right, so today we're going to look at part 2, okay, unit circle trig. Okay, same section, just part 2. Instead of just looking at the quadrantal angles like we did yesterday, okay, those were the ones we just went over, 0, 90, 180, 270. We're going to look at finding the trig functions of angles 30, 45, and 60. Okay, those are the 3 we're going to look at today. So what we're basically going to do is when we draw any one of those angles, either the 30, the 45, or 60, is we end up making a triangle out of it. Okay, like that. I'm not going to draw every triangle at once because it starts to look confusing. But that's the basic idea. Okay, we're going to make a triangle, and we're going to figure out how long each side is. Okay? If we can do that, if we can figure out how far to the right we go, in other words, the length of the bottom, and we can figure out how far up we go, that's the coordinate. How long is the bottom? That's x. How tall is the triangle? That's y. Okay? So we have to find those 2 things. We only have to find them one time. Once we know the coordinate, we just memorize it, write it down. We never have to find it from scratch again. Right, so I'm going to start with the triangle I just drew. Okay, the 45, 45, 90. All right, so on your unit circle, this would be 0. That's 90. 45 is halfway between the 2. Okay, so I'm going to draw my 45-degree angle right there. Okay, any questions so far? Now, what we're going to do is make a triangle out of it. Draw a line straight down perpendicular to the x-axis. Okay, so that's 90. Okay, and this angle is 45, okay, because I've rotated counterclockwise 45 degrees. How do I know this angle at the top is also 45? Yeah, they all have to add up to 180. Okay, so if the bottom one is 45 and that's 90, if you add them up, that's 135. Yeah, 45 added to that is 180. All right, there's one side of this triangle we already know the length of. Okay. Somebody remind me from yesterday, what kind of circle is this? Yeah?
A unit triangle?
A unit circle. Yeah. So what's special about a unit circle? Yeah?
The radius is 1.
The radius is 1. Well, the radius of this circle, there's another name for it if you look at it in terms of this triangle. It's the what? It's the hypotenuse. Okay, so the hypotenuse is 1. Now that doesn't directly tell me what I want. I want to know the length of the bottom, and I want the height. But there's a connection in this triangle between the base and the height. Does anybody know what the connection is? They're the same. Okay, this is an isosceles triangle. It's 45, 45, 90. 2 angles the same, 2 sides the same. Right? I don't know the base and I don't know the height, but I know they're the same. Since I don't know it, how could I represent it for now? X, and now they're the same, so do I need 2 different letters? Yeah, use the same letter. Okay, let's call the length of the bottom x, and we'll call the height x. Okay, you can only do that if they're the same, and they are, because the angles are the same. All right, now we need to just solve for x. Okay, anybody know a formula or theorem you can use in a right triangle to find the sides? Yeah, very good. We can use the Pythagorean Theorem. Now, we're not going to use a, b, and c because I don't have a, b, and c up here. I have x, x, and 1. Can anybody tell me what the Pythagorean theorem would look like? Filling in x, x, and 1. Perfect. My leg squared plus my other leg squared equals my hypotenuse squared. Okay, if we add up x squared and x squared, Shane, how many x squareds is that? So we have 1 here and 1 here. We'll try again. It's 2. I like that a little better. Okay. So 2x squared equals 1. Okay. Next step, I want to put this 2 on the other side. So how would we move that 2?
Divide it.
Yep, divide it. And divide it. So now I have x squared equals a half. But I want x. So how do you get rid of an exponent of 2? Yep, take the square root. And when you take the square root of a fraction, just do the top and the bottom separate. Okay, so we get x equals, what's the square root of 1? 1. And the bottom square root of 2, you can't simplify it. But I don't want to leave the root in the bottom. So how do we fix it?
Square root it.
Yep, multiply by the square root of 2 over the square root of 2. Okay. And what will my final answer be? Square root of 2 over 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is square root of 4, which is 2. So that's the length of the bottom. And that's also the height. So now, using that, let's see if we can write our coordinate. Okay. How far is it to get from here to here? How long is that segment in red?
Square root 2 over 2.
Yep. You go to the right, square root 2 over 2. And then how far is it from here up to there? That's also square root 2 over 2. That's your coordinate every time you do a problem with a 45-degree angle. Okay, so what I would do, rather than having to do this every time, just memorize the coordinate. Root 2 over 2, root 2 over 2. Okay, any question on the coordinate? Mm-hmm.
Would that also work for like 135?
Yes, that's what tomorrow's about. Okay, I wasn't going to show it yet, but if you had 135, that's right here. 135 is a mirror image of this triangle, right here. The only thing that changes, instead of both of these numbers being positive, is one of them is going to become what? Negative. Okay. For 135, it would be the x. It also works for 225. In this case, negative, negative. And it also works for 315. Positive, negative. It's the same two numbers every time. The only difference is sometimes one or the other is negative. Okay. But these other quadrants, that's going to be tomorrow. Okay. But if you already understand that, then that's really good. Okay. Today I'm going to keep everything in quadrant 1. Okay. Positive, positive. Right. So now we're going to use that coordinate, see if we can find the 6 trig functions of 45. Okay, when they give you a question like this, they gave me an angle. That's fine, but what do I really need to do unit circle trig? I got to have the coordinate. Okay, if I can't get the coordinate for this angle, I'm stuck. I can't do anything. Okay. So this is the part where either now you go figure out the coordinate or you just have it memorized and you just write it down. Okay, so what's our coordinate for 45 degrees? Yeah. So that's x, that's y. Okay, you guys have already seen this coordinate yesterday. If you go back and look at some of your examples, we did this problem from here. Okay? The only difference is I gave you the coordinate yesterday. Today, you had to give it to me. Okay? Right, so now we'll just go through and find all 6 trig functions. Taryn, what is my sign? Yep. And do you remember, since they're the same, is sine the x or the y value? Y. Okay, so in this case, since they're the same, if you made a mistake, you'd get lucky, but sine is the y. Okay? Cosine is the x. Okay, so cosine is root 2 over 2. Scott, how about my tangent?
Square root of 2 over 2 over square root of 2.
Yeah, imagine just putting like a division sign right here. Tangent is y divided by x. So Scott said it perfectly. In general here, you're dividing two things that are the same. So what do you get? 1. All right. Now, the shortcut, once you have the 3 on the left, what do you do with them to get the 3 on the right?
Flip them.
Yeah, just flip them all. Okay. Does anybody remember what this comes out to once we clean it up? Yeah, you get, I'll just put it here, 2 square root of 2 over 2. And then what happens there? The 2's cancel out. And you're left with just the square root of 2. Okay. What about my secant of 45? Same thing. If the sine and the cosine are the same, the secant and the cosecant are the same. And what about cotangent 45? What are we doing with this number? Just one word? Flip it. That's it. 1 over 1, when you flip it, it's still 1 over 1. Okay, there's two numbers that stay the same when you flip them. 1 and -1. Yep. Okay, you're not going to see any undefineds today. Okay, the reason you're not going to see undefined, none of our coordinates are going to have a 0 today. Okay, so any questions on 45-degree angle? All right, so let's take a look at the 30, 60, 90. All right, so this time I'm going to draw a 30-degree angle. All right, so here's 0. Here's 90. Okay, 45 would be right in the middle. Just put 30 a little less than halfway. Draw your hypotenuse. And then draw your height from that point to the x-axis. Okay, that is my 30. Okay, we kind of did this before, but how do I know this top angle is 60?
Yeah, 190.
They have to add up to what?
90.
Yeah, well, you could say these other two angles have to add to 90. Well, altogether they add to 180. Yeah, same thing. Okay, so 30 plus 60 plus 90 gives me 180. Okay, hypotenuse. How long is that side? 1. It's 1 because it's the radius of the unit circle. Unit circle, radius of 1. All right. Do we have an isosceles triangle this time? No. We have two different angles, so we'd have two different length sides. So don't write this down, but if we were going to use letters, we'd have to do it like that. The problem is with two different letters, we can't solve it. We can only have one letter. All right, so exactly the same idea is not going to work. But I'll give you a hint. Okay, the hint involves temporarily making a copy of this triangle, and then I want to do something with it so I can kind of match it up with the one that's already there. Anybody see what I could do with this second triangle? Yeah, I'm going to flip it. And I'm going to flip it like that. In fact, let me move it up a little bit. Move that up. Okay. Now I'm only going to need this triangle temporarily. I'm going to be able to get rid of it in a second. What kind of triangle did I just make, the big triangle? It's equilateral. 60, 60, 60. What does equilateral mean? All the sides are the same. Okay. So how long is each side in this triangle? 1. Okay. The side's 1, the bottom side's 1. The right side is 1, and that's the most important. If the right side is 1, and it's composed of two segments that are the same length, each one of them has to be how long? They each are 0.5 or they're each 1/2. Okay? So now we just figured out this side. It's 1/2. We don't need the bottom triangle anymore. Okay? Any question on how we got that side as a half? Okay? There's also a rule from geometry that says in a 30, 60, 90, the short leg is half the hypotenuse. If you knew that, you could just use that fact as well. All right. Now, what's the only side we don't know? Yeah, the bottom. So now call it x. That's fine because now we just have one letter. And we'll solve it with the Pythagorean Theorem. X squared plus a half squared equals 1 squared. Tyler, what's a half times a half? 1/4. Okay, next thing I want to do, get the 1/4 on the other side. So Mitch, how do I get that 1/4 on the other side? Well, you're thinking multiply by the reciprocal. If this plus sign wasn't here, you'd do that. But we want to do the opposite of addition. Subtract a 4th. Okay, so we get x squared equals, what's 1 take away a quarter? 3/4. And last step, get rid of that exponent. Yep, take the square root. And we get x equal, does the square root of these simplify nicely? No. So just leave that. How about square root of 4? 2. So x is the square root of 3 over 2. Okay. Now we can write the coordinate for 30 degrees. Okay. How long is the bottom side? Square root of 3 over 2. And what's the height? 1/2. Okay, that's always the coordinate for 30 degrees. Root 3 over 2, 1/2. Okay, the last coordinate we need is 60. Okay, but watch what happens if I draw the 60. I'm going to draw it with the same triangle here. Here's my 60. Just like that. What do you think the coordinate of the 60 is going to be?
The opposite.
Yeah. The x and the y just switch places. Okay. When you have it as the 60, what basically happens is now the 60 is at the bottom, and the short side is the base. Okay, right here. And then the long side becomes the height. So it's like you're taking this triangle and then standing it up. Okay, so they switch places. 1/2 root 3 over 2. Okay, and honestly, I never memorized the order. Okay, as long as you know you have the number 1/2 and the number root 3 over 2, I'll show you how you can figure out which one is x and which one is y just by making a picture. Okay, the only thing you have to remember is the short side is always a half. Okay, just keep that in mind. The short side is across from the short or small angle. Short side is always a half. Okay? And then the bigger side has to be root 3 over 2. All right, so let's see if we can figure out 6 trig functions of pi over 6. Okay, what might you want to do right away here? If you don't like how this problem looks, what could you do? Yeah, just change this to degrees. Okay, we're not used to working in radians as much. Why don't we make it degrees? Then it'll be what we're used to. Does anybody know what, or have a guess what pi over 6 is in degrees? It's 30 degrees. If we didn't know that, how would you figure it out? 180 over pi. 180 divided by 6. Okay, so that's how you convert it from the first week if you don't remember. All right, so now we know our angle is 30 degrees. What do I need next?
You need the x and y.
Yep, I need the x and the y. Okay. When we're dealing with the 30, 60, 90, what are the two numbers that are involved? You don't have to tell me the right order. Just tell me the numbers.
1/2.
1/2.
Square root 3 over 2.
And the square root of 3 over 2. Okay. All I got to remember is 1/2 is across from the short side. Okay, so make a sketch of a 30-degree angle. Okay, just try to draw it roughly where it would be. Which side here is the short side? The height or the base? The height. And I said the short side is always how long? That's my half. So now I know 1/2 is y. And what's the long side? That's my square root of 3 over 2. Okay, so now I know the coordinate. Root 3 over 2 is x. 1/2 is y. Okay. So I didn't memorize which one goes where. I just figured out by the picture, looking at the short side and the long side. Any question on how I got that coordinate? Okay, on the test, that's going to be the first part of each problem. Step 1 is going to be tell me the coordinate for the angle, and then I'm going to ask you for one of these 6. I'm not going to ask you for all 6 in the same problem. Okay, but we'll practice all 6 since you don't know which one it's going to be. All right, start with sine. Okay, Zach, what's the sine of pi over 6? Yep, half. You do the cosine for me too?
Cosine? That'd be x.
Yep, cosine's the x, and what's my x here?
3 root square root 3 over 2.
Yep, square root of 3 over 2. And now for the tangent, just imagine putting a division line here and dividing these two fractions. Okay, when you divide them, what's going to happen? Yep, the 2's are going to cancel. Okay, anytime you divide fractions with the same denominator, the denominators cancel, and you're left with 1 divided by square root 3. Okay, is that answer okay for a final answer?
No.
No. If we fix it, multiply by square root of 3. And that's what you get. Don't get rid of this other answer, though. Keep this here, because we're going to come back to it in a second. Okay, cosecant, I'm going to flip 1/2, and I get 2. For my secant, I'm going to flip that and get 2 root 3 over 3. Any question on how I did that one? You'd flip it, but then you'd have root 3 in the bottom, and you'd have to multiply by root 3. Okay, now for cotangent, I have a choice. I can either flip the first one, or I can flip the second one. They're the same thing, just written differently. Which one here would be better to flip? First one or second one? Yeah, why the first one? Yeah, if you flip it, you don't have to simplify it. The root goes to the top and you're done. If you flip the second one, you've got to go through the whole thing all over again to get the same answer. So what's the cotangent? Square root of 3. Any questions on finding the 6 trig functions of 30 degrees? All right. So the last one, why don't give that one a try. find the six trig functions of 60. Now, when you do 60, you're going to see all the same answers you get when you do 30. They're just going to be in different spots. Okay? But they're going to be the same answers we just had. All right, so we've got our angle, it's 60 degrees. What's first thing I got to find? I got to get the coordinate. Okay, unfortunately, that's the thing. If you mess up the coordinate, then everything you do after that, it's going to come out wrong. All right. So there's 60 degrees. What side is the short side here, the base or the height? Base. And short side is always how long? 1/2. Long side? Perfect. So now I know x is a 1/2, y is √3/2. So the only difference between this problem and the last one, where did I do it? X and y are just going to change places. There it is. Okay, that's all that's going to happen. All right, so my sine, Brielle, you think you could tell me the sine?
I put it in 1
That's going to be my cosine. Okay, cosine is the x, sine is the y. 3/2. How about my tangent? Square root of 3. Anyone see that? When you divide these, the 2's cancel. Now we're going to have to flip that in a minute. There's no denominator. What could I put here if I need to? Yeah, just put a 1. Okay, if you need to when you flip it. What's my cosecant? 3/3. My secant? 2. It's always nice when there's no root. Makes it very quick to flip it. And my cotangent here, square root what? Perfect. Okay, so if you compare this to the previous one, you should see all the same answers, except the sine and the cosine switch, the secant and the cosecant switch, and the tangent and the cotangent switch. Okay, that always happens with 30s and 60s. Okay, any question on that? All right, let's look at this one. Okay, let's say I had a point let's do 120. What quadrant is 120 in? It's going to be in the second quadrant, about right there. Okay, roughly. Here's my triangle. Now, does this look like a 30, 60, 90 triangle or 45, 45, 90?
30, 60.
Yeah, it definitely has a side that's long and a side that's short. How long is the short side? Half. And how about the long side? Okay. And I said this angle right here is 120. Right?
Would that be negative? Yeah.
Well, when we write the coordinate for 120, how do you think you'd write that 1/2? Yeah, it would be negative because you went left. And how about the height? Would that be negative or positive? Positive, because you went up. Now, if I asked you to find any of the trig functions, you do it just like we did. The only difference is now you have a negative. Okay? That's all that we're going to look at tomorrow. Flipping the triangle we look at today into other quadrants. Okay, and the other thing we're going to look at is if you had a problem like this. Is that number a multiple of 30? No. Is it a multiple of 45?
No.
No. So this is not a problem we can do on the unit circle. Okay. Anytime you have angles that are not multiples of 30 or 45, we type it into the calculator. Okay, we have two choices about what mode we could be in, degrees and radians. What problem do you think this one is in? Yeah, it's degrees because it has the circle. Right? So what I'd have to do is switch to degrees, type in sine 42, hit enter, and I get 0.669. So if you try it on your own, make sure that your calculator is giving you that. Now, what if I did this? What's the difference between these two problems?
One's in radians.
Yeah. This bottom one is radians. If there's no degree symbol, you always assume radians. So easiest way to do it, change your calculator to radians, type in the same thing again. Okay, but completely different answer. Okay, negative 0.917. Okay. Biggest problem I've seen with this is people accidentally have their calculator in the wrong mode for this whole section of the test. This is the easiest part as long as you put your calculator in the right mode. Okay, so just ask me before the day of the test, how do I change the mode, and I'll help you figure it out. Okay, so basically that's what we're going to look at tomorrow, and I'll expand on this a little. We'll go through cosine, I'll show you tangent, secant, cosecant, and cotangent. Okay, I would watch the video, because if you look at your calculator, there's no button on here for secant, cosecant, or cotangent. You can't type in secant of 57 degrees directly. We can type it in, but we got to do it indirectly. And I'm going to show that tomorrow in the lesson. Okay. Okay, so any questions mainly on just what we did today, not so much the calculator stuff? All right. Okay, so the homework will be a worksheet, has 10 questions, and I'd like you to try these 5 problems. Okay, these I didn't get to put on the worksheet, so just copy these 5 problems down. And you've got the last 25 minutes or so to get started on the homework.